Today we'll be working on frequency distribution and graphs. This is the second chapter. So let's begin with the definition of frequency distribution. When we say frequency distribution, let's find out what is this. To describe the situations or draw a conclusion or make inferences about the event, the researcher must organize the data in some meaningful way. So after we collect the data, what we do is we try to arrange the data in a meaningful way. And the most convenient method of organizing the data is to construct a frequency distribution. So that is what we are going to work here first. We are going to learn how to construct the frequency distribution. That is the first thing we are doing here. A frequency distribution is the organization of raw data in table form using class and frequency. So that is the definition. Whenever we say frequency distribution, it is the organization of raw data in table form using class and frequency. So as it is defined here, in order to make the frequency distribution, we make a table and we'll have the frequency or count how many of those items are there. Basically, there are three types of frequency distribution that are mostly used. The first one is called the categorical frequency distribution. This is for the categorical data. And then the other two, the grouped frequency distribution, okay, the grouped frequency distribution and the ungrouped frequency distribution. Those two are for the numerical data. The first one, categorical frequency distribution, that's for the categorical data. And these two are for the numerical data or qualitative data. And they are of two types, ungrouped frequency distribution and grouped frequency distribution. Ungrouped and grouped frequency distribution. Example, categorical frequency distribution. So here we are going to create a categorical frequency distribution for the data given here. So we are going to read the problem in detail and then we are going to construct the table. An organization surveyed 50 randomly selected individuals and asked them primary way they receive daily news. So here an organization did a survey and they selected 50 randomly selected individuals. So their sample size is 50. And what they ask is, how do they receive news every day? Their choices are, there are three ways that they are receiving the news. The first one is via newspaper, generated by N here in the collection. The second one using television, T, the radio, R, and internet, I. So these are the four different ways of collecting the data. So you can clearly see the data here does not involve number. It has N for newspaper, T for television, R for radio, and I for internet. So this is purely a categorical data. What we are asked to do is we are asked to construct a categorical frequency distribution for this data. So we want to construct a categorical frequency distribution. So let's make a table here. So what we do is the media or medium they use in order to receive the news daily. There are four different medium. The first one is the newspaper. You can write that here in the table. Newspaper, which is denoted by N. That is the first way they receive the news. The second way they receive news is television. We write here, television denoted by T. Make sure you follow along with me like this. Radio, R. Radio, R. And the last one is internet. Internet denoted by I. These are the four different ways they receive the news. Now what you have to do is we have to write the frequencies for each. So we have to count and write the frequency. So how many of them receive the news from newspapers? So we are going to count like this. So if I go column wise, here is 1N, one newspaper, 2, 3. Then we have 4, 5, 6, 7, 8, 9, 10. I see 10 of them. So 10 of them use newspaper to receive the daily news. Now let's go to television. How many of them use television? I don't see any here. We have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So 16 of them receive the news, daily news from television. Now radio, denoted by R, let's count how many are there. We have 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12 of them receive the news via radio. Now, internet. Let's find out how many of them receive the news from internet. We have I here, 2 of them. 2. Then here we have 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of them, they receive the news from internet. So here what we did is we represented the data using frequency. We can clearly see 10 of them use newspaper to receive the news, 16 of them use television to get the news, 12 of them use radio to get the news, and 12 of them use internet to receive the news. So this table that we have created here, this is called the frequency table. This is called the frequency table. And if you see the data represented like this, then we say that this table is the frequency table or frequency distribution of the data here. We have the categorical data. So this is the frequency distribution for the categorical data given here. Example, the blood urea nitrogen or BUN count of 20 randomly selected person is given here in milligram per deciliter. So that is the amount of the urea nitrogen, blood urea nitrogen count for 20%. It's given here, and the unit used here is milligram per deciliter. That's after the lab is performed. What we have to do is we have to construct an ungrouped frequency distribution for the data. When we say ungrouped frequency distribution, we are just counting like how many 18s are there, how many 11s are there, how many 20s are there, and things like that. We are not making a class. We are not checking like how many are there between 11 and 15. If we do that, that will be a group. But here we are doing ungroup. So we are counting the individual data point and we are making a table. So construct an ungrouped frequency distribution for the data. Also, we have to find the cumulative frequency and relative frequency. We are going to talk about these two, cumulative frequency and relative frequency, in a second. But before that, we are going to construct the ungrouped frequency distribution. So what we do is we'll have the data value. For the numerical data, we generally represent the data value using X. So what are the different data values here? You can see the smallest value is 11, I can see. So there is an 11 as a data value. Then I can see 12. If you look at it carefully, there is a 12. And then there is no 13, no 14. There is 15. Look at it carefully. There is no 16, no 17. There is 18. Then you have no 19, but there is a 20. Okay, so 20. Let me write here 2020. So these are the data values that we have. Now what we need is we are constructing the frequency table, construct ungrouped frequency distribution. Okay, ungrouped frequency distribution. So what we do is we list the data value, and now we are going to write the frequency. So if you try to write the frequency, we are going to count like how many 11 are there. Here is 1, here is 2, here is 3. There are 3 11. How many 12 are there? Let's count. 1, 2, 3, 4. Yes, there are 4 of them. Now we have to count 15. How many are there? 15, here is 1, 2, 3. 3 of them. 18, 1, 2, 3. This is 4, 5, 6. 6 of them. 6 of them. So let me write 6 there. 6 of them. Then we have to count how many 20 are there. 1, 2, 3, 4. You have 420. So this is your frequency table, ungrouped frequency table. We are counting the individual data points, so it is called the ungrouped, or sometimes we also call it individual frequency table. Now, if you look at the information given here, it is a sample of 20 individual selected persons. So 20 randomly selected persons. So if you add all these, 3 plus 4 plus 3 plus 6 plus 4, if you add all of them, okay, if you add all frequency, sum of all frequencies equal to 20. This is how we write the sum. Sigma f, sum of all frequencies is equal to 20. If you add all these, that's equal to 20 because 20 individuals were selected. Or if you count the data point here, there are 20 pieces of information. That's the meaning of that. So we constructed the ungrouped frequency table. Now, after this, we are asked to do a few more things. Next we want the cumulative frequency. The next thing we want is the cumulative frequency. Cumulative frequency is denoted as CF, and it is the accumulation of frequency. Like if you look at this table now, how many 11 are there? There are 3 11. So we write 3 first. Then after that, when we go to second line, how many 11 and 12 are there? If we count all 11 and all 12, how many are there? We have 3 11 and 4 12. So 3 plus 4 equal to 7. That is the cumulative frequency. We are accumulating or we are adding the frequencies together. When you go to 15, how many 11, 12, and 15 are there? That's the meaning of that. We have 3 11, 4 12, and then 3 15. So if we add 3 plus 4 plus 3, that should be 10. That is 10. And then what is the cumulative frequency for 18? If we ask that question, that is the frequency for 11 plus frequency for 12 plus frequency for 15 plus frequency plus 8 for 18. So that will be 16 if you add all of them. And then if you go to the last one, what is the frequency for 20? Cumulative frequency for 20. It is the frequency for 11, frequency for 12, frequency for 15, frequency for 6, and frequency for 20. If you add all of them, that is equal to 20. So that is the cumulative frequency. So here we got the frequency and cumulative frequency. The next thing we want to find is called the relative frequency. So in next column here, we are going to find relative frequency. Relative frequency, we write RF, relative frequency. And the formula to find relative frequency is the frequency divided by the total number of observations here. Frequency divided by total number of observation, 20. If we add all frequency here, that is equal to 20. So in order to find the relative frequency, so what we do is we divide the frequency by the total. So for example, for the first one, frequency is 3. So it will be 3 divided by 20. 3 divided by 20. Now, if you find this value in decimal approximately in your calculator up to 2 decimal places, it should be 0.15. So the relative frequency for the first one is 0.15, not 15, 0.15. Relative frequency for 12, frequency is 4, so it will be 4 divided by 20. It will be 4 divided by 20. If you change this to decimal, it should be approximately 0.2. Next, we have 3, so it will be 3 divided by 20. 3 over 20. Frequency divided by the total, 0.15. The next we have 6. 6 divided by 20. 6 divided by 20. The value must be 0.3. 0.3. And the last one, our frequency is 4. So it will be 4 divided by 20. If you perform this division, 4 divided by 20, it will be 0.2. 0.2. So these are relative frequencies. Note one thing here, if you add relative frequencies, if you try to add relative frequencies, let me write here, sum of relative frequencies. If you add these values like 0.15 plus next one is 0.2, then next one is 0.15, then you have 0.3, and the last one is 0.2. You'll see a magic here. Check here. 0.15 and this 0.15. If you add 0.15 and 0.15, that is 0.3. 0.3 plus 0.2, 0.5. 0.5 plus 0.3, 0.8. 0.8 plus 0.2, that is equal to 1. So always remember, when you add a relative frequency, it must be 1. So that's the quick way you can check. You find the relative frequency and then try to add and see whether it is 1 or not. If you get 1, you are doing it right. Always remember, relative frequency is equal to frequency divided by the total number of observation or sum of all frequencies. Example, the ages at the time of death of those vice president of United States who passed away are listed below. So these are the ages of the vice president at the time of their death. We have to use this data to construct a group frequency distribution. And when we make the group frequency distribution, we have to use 6 different groups, or we have to use 6 different classes, use 6 classes. Then later on, we have to find the cumulative frequency and relative frequency. So first, what we are going to do is, we are going to look at this data and we are going to find what is the smallest data value. So if you look at it carefully, let me write here, smallest data value is, you can see one of the vice president passed away at the age of 51. So that is the smallest value. 51 is the smallest data value. If you look at the largest data value, okay, let's observe the data here. The largest data value, you can see the values there. So when you look at this data value, we can see that the highest data value here is 98. We don't have anything greater than that. So that is the smallest and the largest data value. So in order to construct the grouped frequency distribution, we need the smallest and the largest data value. Meaning of that is, we have the data value ranging from 51 years through 98 years. So this is the range from 51 up to 98. That is the range. So if you want to find the range or the difference, it is 98 minus 51, or 98 minus 51 is 47. So this one, the data values ranging from 51 up to 98, we want to divide that into 6 different classes. We want to divide this into 6 different classes. If I do that, it will be 2 classes. If I do this, then you can see there are, give me a second. If I do this, this is 3 here, 1, 2, 3. Then count there, 4, 5, 6. So we want to divide it like this. So we want to divide this width into 6 different parts. So divided by 6, divided by 6. So you will get 47 divided by 6 is approximately, not exactly, but approximately 8. If it was 48, it will be exactly 8. So I'm writing approximately 8. So we have to go by 8. So 51 up to 58. 51 plus 8. So what you can do is, you don't have to start exactly at 51. You can do a little bit down, and you can go a little bit above 98. What is the meaning of that? Let's see. Meaning of that is this. We can make the class, or you can also call group. What I'm going to do is, here is 51. I'm going to start a little bit down, but I'm going to include all the data information. So what I'm trying to do is, I'm going to start at 50, and then I'm going to go by a difference of 8. So 50 plus 8 is 58. That is my first class. In my first class, I have 50 up to 58. And then after 58 is 59. 59 plus 8. 59 plus 8, 67. Then after 67 is 68. 68 plus 8. Okay, we are going by 8. So 68 plus 8, 76. After 76 is 77. 77 plus 8 is 85. Then 86, we start at 86. 86 plus 8. 86 plus 8 is 94. Then we start at 95. 95 plus 8 is 103. So you can see in these group, we make a group. We are grouping the A's from 50 to 58, 59 to 67, 68 to 76. And you can also see that all these data values from 51 up to 98, all are included. We group the data into 6 different classes, 1, 2, 3, 4, 5, 6, 6 different classes. So this idea of constructing the frequency distribution, this is the group frequency distribution. So frequency, what we do, we'll count how many data values are between 50 and 58. So if you count here, you'll see that there are 5 data points between 50 and 58. 59 through 67, if you count how many are there between 59 and 67, you'll see 10 of them. Similarly, between 68 and 76, you'll see 10 of them again. 77 through 85, if you count how many data values are there, that is also 10. And then how many are between 86 and 94? If we observe the data and count there, we'll find that there are 3 of them. And then how many are there between 95 and 103? 95 and 103, only 2, these 2 values. So 2 of them. So that is the frequency distribution. That is the frequency distribution. So we have the grouped frequency distribution here. So after we have the group frequency distribution, the first thing is to construct the group frequency distribution. Next, we are asked to find the cumulative frequency. So cumulative frequency, from the previous example, we know that it is the addition of the frequency. We are accumulating the frequencies together. So for the first class, the frequency is 5. So the cumulative frequency will also be 5, no doubt on that. For the next one, we add these two. So 5 plus 10, that is 15. Now we add up to here. So 10 plus 10 plus 5, which is 25. Okay, and then we add 10 more in the next one. That'll be 35. 35. Then we add 3, 35 plus 3, 38. Then plus 2, that is 40. So meaning of that is, here we have 40 pieces of observation. So we have 4 here, 4 times 10, that is equal to 40 pieces of observations are there. So if you add all frequencies, you can write sum of all frequencies is equal to 40. So if we add all these numbers, these numbers, how many are there? If you want to find how many pieces of information are there, or data about how many vice presidents are given, you'll find that it's 40. So that's the cumulative frequency. And the last thing we want is the relative frequency. So we already know how to find the relative frequency. So relative frequency is equal to frequency divided by the total. Total is 40. So in this case, the first one is 5 divided by 40. If you change this to decimal, 5 divided by 40 in your calculator, you should get 0.125. Next one is 10 divided by 40, frequency is 10. For the second class, frequency is 10. 10 divided by 40 is 1/4 or 0.25. Next one is also 10 divided by 40, which is 1/4 or 0.25. Next is also 40, so 10 divided by 40 is 0.25 again. Then next one is 3 divided by 40. 3 divided by 40. If you perform that calculation in your calculator, you should get 0.075. 0.075. The last one is 2 divided by 40. Frequency is 2. 2 over 40 or 1 over 20, which is 0.05. So always remember, when you're calculating the relative frequency, it is the frequency of the class divided by the total number of observation or total frequency. So here we completely solve the problem. We group the data based on class. We have the frequency, so it is the group frequency distribution. And on the same group frequency distribution, we find the cumulative frequencies and also the relative frequencies. Histogram. Histogram is the graph that displays the data by using the vertical bars of various height to represent the frequencies of the distribution. So when we talk about histogram, this is the graph to represent the group data. We have a group data. For example, we have a data from here to here in the second picture. That's one group. That's the second group. You have a third group. You have a fourth group. And then we draw the vertical bar, which are adjacent to each other based on frequency. If a group has the highest frequency, it will be the tallest. If a group has a smallest frequency, it will be the shortest. So we make the histogram using the vertical bars of various height that represents the frequency. We need this histogram because histogram is a plot that lets you discover and show the underlying frequency shape. We'll be talking about shape of distribution a lot in the course. So it will help you to determine the shape of the distribution of the data. When I say the shape, this is the meaning of that. If you look at the first histogram here, you can see that all bars, they are of pretty much the same height. Not exactly, but they're pretty much the same height. So if the height is pretty much the same, we say that the distribution is uniform. So the first graph here, it represents uniform distribution. Now, if you look at the second one, if you try to draw the graph connecting the top of the bars, that is when you start from the tallest bar, and if you draw it like this, okay, if you draw on the other side from the tallest bar like this, you can see that towards the left, it has a long tail. We start from the middle, we start from the tallest bar. This side, it has the longer tail of distribution. So the data is more towards the left. When the data is more towards the left, we say that this data is not uniform. This is left skewed. It is more towards left or more towards the negative numbers. That's why we also say negatively skewed, left skewed or negatively skewed. We can also add this, negatively skewed. So we are looking at the histogram and we are talking about the shape of the distribution. If you look at this one, third graph, here is the tallest graph. From there, you draw the graph connecting the top of the bars like this, all the way to the down. That is the tail on this side. On the other side, if you try to draw, you can see towards the right, you have the tallest, the longest tail. The longest tail of distribution is towards the right. Meaning of that is you have more data towards right. And we say that this data is right skewed. It is right skewed or it is more towards the positive numbers, more towards the positive numbers. So we say this is right skewed or positively skewed. This is right skewed or positively skewed. And the last one here, let's look at this one. If you start with the middle one there and try to draw this graph, or if you try to draw the frequency distribution graph like that, you can see that the tails are pretty much same length on both sides. When the tail of the distribution is pretty much same on left and right, we say that the distribution is normal distribution. It has some other name also. We say normal distribution, or we also say symmetrical distribution. Symmetrical distribution, or we also say it is bell-shaped distribution. Bell-shaped distribution. So these are the different names of this distribution. If the data is equally distributed on the left and the right, we say it is a normal distribution, symmetrical distribution, or bell-shaped distribution. So we can quickly look at the histogram to decide whether the data is uniform, left skewed, right skewed, or normal distribution. And also, Histogram is constructed using the grouped frequency distribution. A histogram is a quick way to get information about the sample distribution without detailed statistical or graphical analysis. We can just look at it and we can tell in what direction we have the distribution. Okay, histogram is constructed using group data. Example, construct a histogram to represent the data shown below. Use the constructed histogram and state the shape of distribution. So here we have the group data given or group frequency distribution given, and we are asked to draw the histogram. So what we do is along the x-axis, we'll have those groups. Along the x-axis, we'll have the groups. So let's do that. Let's draw the x-axis first. Let me draw here. That is my x-axis. Make sure you also draw this in your note catcher. And then we need the vertical axis or y-axis here. So let me draw the y-axis. So that is my y-axis. I'm showing you the detailed process of drawing the histogram. Now, along the x-axis, as I told you, you'll have the class or the groups. So we have the data is starting at 55 and goes up to 60. So you can start anywhere on this curve, I mean, along the x-axis. I'm going to start here, somewhere here, and I'm going to call that 55. So we have 55 to 60. The next one is 60 to 65, 65 to 70, 70 to 75. Then we have 75 to 80, 80 to 85, 85 to 90, 90 to 95, 95 to 100. So those are the class. 55 to 60 is first class, 60 to 65 is second class, and so on. Now along the y-axis, we'll have the frequency. So frequencies are 1, 2, 4, 5, 10, 4. So highest is 10. I'm going to go by 2. I'm going to count by 2. So let's do this. 2, 4, 6, 8. Highest is 10. So I'm going to stop there. Now the first one, first class is 55 to 60. The frequency is 1. 1 is between 0 and 2. So we'll draw a vertical bar of height 1. So here we draw a vertical bar of height 1, like this. Vertical bar of height 1. The next one is also the vertical bar of height 1. Let's do it. 60 to 65. It is also the vertical bar of height 1, like that. Next one, vertical bar of height 4. Okay, we'll go 4 units up. 4 units up, like that. So that is your next bar. The height is 4. Next one, we have to have a bar of height 5. Okay, height 5 is a little bit above that. Between 4 and 6 is 5. So that is your bar with height 5. Next, we have to draw a bar of height 10. So we have to go all the way to the top. Okay, 10 is up to there. 10 is up to there. Because 75 to 80, you have a frequency of 10. So we go up to 10. Like that. Frequency of 10 there. Then 80 to 85, frequency 4. 80 to 85 is frequency 4. So that is the height. Frequency 4. 80 to 85, that is the bar of height 4 units. The next one, bar of height 3 units only. 3 units only, like that. So that is the bar of height 3 units. Next one, bar of height 2 units only. 2 units is that much. And then the last one, we have a bar of height 1 unit only. 1 unit only. Okay, sometimes people write the frequencies on the top. If you want, you can also write. So meaning of that is we write like this. The frequency is 1, this is 1, this is 4, this is 5, this is 10, this is 4, this is 3, this is 2, and this is 1. And if you want to find the total number of observation, how many data points were there, you can add all these numbers, or you can add all the numbers on top of the bar. If you want to beautify the bar, if you want to make the bars a little beautiful, you can set them using your pencil, or you can use some beautiful color to represent that. So you can definitely make it beautiful. You can decorate it and make it look beautiful. So you can do that in your note catcher, so that when you scan and upload in color format, I can see your beautified graphs. Okay, this is our histogram. Okay, let's now label this one. Along the x-axis, we have the temperature. So we have temperature along the x-axis. And we have number of days along the y-axis. So we'll write that. Number of days along the y-axis. So this is our histogram. Now what you have to do is we have to use the histogram to state the shape of the distribution. So in order to look at the shape of the distribution, we try to draw that distribution. So if you start with the highest bar there, and if you try to draw the graph like this, that's how the graph will be on the left side. On the right side, it is just like that. So what you'll see is you have pretty much the distribution on the left and the right of the middle graph. Okay, if you look at the middle graph, the distribution on the left and the right are pretty much equal. So meaning of that is this distribution is a normal distribution. We are asked to write what type of distribution is this? What is the shape of the distribution? It is normal distribution, or you can say it is symmetrical. It is symmetrical, or I told you it is also called the bell-shaped. You don't have to write all of these. You just have to write one name, and that's okay. You can say bell-shaped, or you can say symmetrical, or you can just say normal distribution. If you just give one name, that's okay. So you can see the data on the left and the right of this tallest bar are pretty much equal. So it is a normal distribution, or it is a symmetrical distribution, or bell-shaped distribution. Frequency polygon. When you say frequency polygon, it's a graph that displays the data using the line that connects the points plotted for frequencies at the midpoint of the class. So you can clearly see when you talk about the frequency polygon, it is a graph between the frequency and midpoint of the class. So this is also the graph to represent the group data. So that's why we say frequency polygon is a graph that displays the data using the line that connects the point plotted for frequencies at the midpoint of the class. So whenever we have a class, that's a group data. So here is the group data, and we are asked to construct the frequency polygon. So using the frequency distribution given below, construct the frequency polygon. Let's give a try. Let's try this one and construct a frequency polygon. So because it is a graph connecting the various points, we need the x-axis. So let's draw x-axis here. Okay, this is my x-axis, for example. And we also need the y-axis. Let's draw y-axis. That is my y-axis. Oh, no. Okay, there we go. That's my y-axis. Now what we need to do is we need to label the x-axis and y-axis after we have those two axes here. Along the x-axis, you can see we have the groups. So we are going to have the midpoints along the x-axis. Midpoint of the class, 50 to 60, that's 55. 60 to 70, 65. 70 to 75, the middle point is 75. 80 to 90, middle point is 85. 90 to 100, That's 95. 100 to 110, that is 105. So we'll have midpoints along the x-axis. Midpoints along the x-axis. Let's plot those midpoints. 55, 65, 75, 85, 95, then we have 105, 105. So those are the midpoints. Then along the y-axis, we need the frequency. We have a maximum frequency of 12. So I'm going to count by 2. Let's do this. 2, 4, 6, 8, 10, and 12. So we are going to plot the midpoint and the frequency. So the midpoint of the first class, if you want to write it down there, you can also write. The midpoint for the first one will be 55. This is 65. Midpoint here will be 75. Midpoint is 85, 95, and 105. That's what we have done. Now, when the midpoint is 55, if you look at your screen, you'll see this. When your midpoint is 55, the frequency is 5. So midpoint is 55, the frequency is 5. So let's plot that point. 55 and 5 is somewhere there. That's the point. Next one, 65 and 12. When the midpoint is 65, the frequency is 12, all the way up there. Hold on. 65, 12 is there. That is the midpoint. The next one, midpoint and the frequency. We have 75 and 10. When the midpoint is 75, this one, the frequency is 10 up there. So 75 and 10 is this one, 75 and 10. Then you have 85, 8. 85, you go to 8. 85, 8. Then you have 95, 3. When you have 95, frequency is 3. And when you have 100 to 110, midpoint is 105, frequency is 2. Frequency 2. So here we plotted the points. See, we display the points and we draw these points using the midpoint and the frequency. If you join these, let's see what you get. Join these from point to point like this. So we are joining these from point to point like this. We get this graph. But this is not a complete frequency polygon, because when we say a polygon, it must be a closed figure. So what we do is, after the endpoint, this is very important. Everybody look at the screen now. After this last endpoint, what you have to do is, here is 105. So the next possible point will be 115. So we have to join this point to 115 on the x-axis. So from here, we have to join it to 115 in the x-axis so that it goes all the way down to x-axis. Similarly, on this side here is 55. So maybe 45 is here. You have to come down to 45. So come down to 45 there. Let's come down to 45 there and join there. Because by joining this, now you can see this is a closed figure. This side it is closed by x-axis, and then this side it is closed by this curve. So this is a closed figure, and there are so many sides here. If you want to count how many sides are there, this x-axis is one side, 2, 3, 4, 5, 6, 7, 8. So this is a closed figure with 8 sides. So whenever we have a closed geometrical figure with many sides, we call it polygon. But in order to construct this polygon, we use the frequencies. That's why this is called the frequency polygon. So always remember, when you're constructing the frequency polygon, is the graph between the midpoint of the class with the frequency. So this is how we construct frequency polygon. Next graph is called ozive, O-Z-I-V-E, ozive. Ozive is a graph that represents the cumulative frequency for the class in frequency distribution. So it is the cumulative frequency. This one is the graph of the cumulative frequency. And when you plot the graph, always what you do is, here we have the group frequency distribution. So we use the midpoint. Here also we use the midpoint. So meaning of that is, if you look at the first class here in this example, using the frequency distribution given below, construct an ogive. The first class is 50 to 60. So the midpoint will be 55. 60 to 70, that is 65. 70 to 80, that is 75. 80 to 90, that is 85. 90 to 100, that is 95. 100 to 110, that is 105. So along the x-axis, we'll have this midpoint, but along the y-axis, we are not using these frequencies. Instead, we'll use the cumulative frequency. We'll use the cumulative frequency. So we have to find the cumulative frequency. Only frequency is given. So let's find the cumulative frequency. Cumulative frequency for the first, it is 5. So next one will be 12 plus 5, which is 17. The next one will be 10 plus 12 plus 5, which is 27. The next one will be 8 plus 10 plus 12 plus 5. So that will be 35. Next, we have 3 plus 8 plus 10 plus 12 plus 5. If you add all of them, that is 38. Then we have 2 plus 3 plus 8 plus 10 plus 12 plus 5, which is equal to 40. So we find the cumulative frequency, because when you draw ogive, we draw the graph between the midpoint with cumulative frequency. So let's draw the axis. Along the x-axis, we have the midpoints. So that's our x-axis. And along the x-axis, as I told you, we'll have the midpoints there. Midpoints along the x-axis. And then we draw the y-axis here. And along the y-axis, we'll have the cumulative frequencies. So we have the cumulative frequencies along the y-axis. Now let's label this x-axis. You have those midpoints, so we are going to label those midpoints, which is 55, 65, 75, 85, 95, and 105. Those are the midpoints. Now, along the y-axis, we need the cumulative frequencies. You can see the maximum cumulative frequency is 40. So along the y-axis, I'm going to count by 5. 5, 10, 15, 20, 25, 30, 35. We have a maximum of 40. We go up to that. So along the y-axis, I'm counting by 5. Now let's draw the graph. Let's plot the point. The first point that we have is 55. When the midpoint is 55, the cumulative frequency is 5. 55, 5 is somewhere there. Next one we have is 65, 12. When it is 65, it is 12, little bit above 10 is 12. So 65, 12. Then we have 75, 27. So when it is 75, go to 27. The next one is 85. When it's 85, the frequency is, cumulative frequency is 35. So 35. Then when you have a 95, you have a 38, pretty close to 40. 38. And then when it is 105, it is 40. Now join these points. So you connect from point to point like this, point to point, just like that, point to point. So this graph that we have created here, this is called ogive. This is called ogive. It's the graph between the midpoint of the class with the frequencies, with the cumulative frequencies. Now, one important use of OSI is to quickly find the total number of observation. For example, if you go to a point corresponding to this one, the highest frequency here is 40. So when you go across, it is 40. So the maximum number of observation here, or total number of observation, is 40. So this is how we construct OSI, which is the graph between the midpoint of the class with cumulative frequency. When you draw the graph with cumulative frequency, that is called OSI. Bar graph, when I say bar graph, this is the graph for on-group data, okay? We draw bar graph, let me write here, bar graph for on-group data, on-grouped or sometimes categorical data. We draw the bar graph for ungrouped or categorical data. So when we say bar graph, the meaning of that is a bar graph or chart. It presents the categorical data with rectangular bars with a height or the length proportional to the values they represent. So you'll see the vertical bars, but they will not be connected. In case of histogram, the bars are connected, but in case of bar graph, the bars are not connected. So bar can be plotted vertically or horizontally. So you can have the vertical bars or you can have the horizontal bars, but the best practice is to draw the vertical bars. Sometimes a vertical bar graph is also called the column chart. That's the other name for the bar graph when you see the vertical bars. Now, here is the example. The table below shows the average amount of money spent by high school seniors. We have to construct the bar diagram to represent this data. You have the categorical data. You can see electronics, school supply, clothing, shoes, and other items. And here you have the amount they spend. So along the x-axis, we are going to have these categories. So let's draw the x-axis and represent those categories. Along the x-axis, you have different categories, and along the y-axis, you have the amount they spend. So let's write that down. Along the x-axis, you have the different items. Okay, and along the y-axis, you have the amount they spend. Amount in dollar along the y-axis. So along the x-axis, let's write those different items. The first one is electronics. I'm just going to write that, electronic like that. School supply, let me write S for the school supply. Clothing, next one is clothing. I'm writing CL for clothing. Then there are shoes. Shoes, I'm writing SH. And then others. Okay, there is room for me to write others. So others. Along the y-axis, we need the amount. Maximum amount is 1,000. The minimum is 85. So I'm going to go by $100, a difference of $100. So 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. 1,000. Okay, 100, 200, let me write 300 there, 400, then that is 500, 600, that is 700, 800, 900, let me write there 1,000. I'm just writing at some difference, but you can clearly see this is 100, then that one is 200, 300, 400, 500, 600, 700, 800, 900, and 1,000. Now let's draw the bar diagram. So we draw the vertical bar of a specific height. The first one, electronics, $1,000. So that's going to be the tallest bar. So draw a bar around that electronics. Around the electronics, draw a bar of height 1,000. So this is the bar of height 1,000, electronics. Next, school supply, 250. Draw a bar around that for 250, height 250, a little bit below that 300. Okay. That is the bar of height 250. Clothing, we have 145, so a little bit smaller than that. 145. Okay, that is clothing. 145. Shoes, you have $85, lower than 100. And then we have others, 200. Others, 200. Like that. As I told you before, you can also write the values on the top of the bar. Like this one is, the first one is $1,000. Next one is $250. You can write like that. The next is 145. Next is 85. The next one is 200. So you can write like this. And you can also beautify your bars. You can color it. You can just set it using your pencil. I'm just doing it like this to beautify the bars. So here we constructed the bar diagram for the categorical data. So this is how we construct the bar diagram for ungroup data or categorical data.